Hello, and welcome to Oracle 11G Real Application Clusters. In this lesson, we're going to learn about what is Oracle's answer to RAC, or Real Application Clusters. First of all, what we can see here is that I have a virtual box set up. Within that virtual box, I have two nodes. I have Oracle RAC 11G R2 Node 1, and then RAC 11G R2 Node 2. I'm going to go ahead and minimize this, and then I'm going to open up both of these terminals. And the reason that I'm doing this is because we want to display to you each individual node. The idea of Oracle 11G RAC, especially R2, is to provide high availability for our very critical or mission critical database applications. A RAC environment is designed to have high availability with minimal or zero downtime. The idea is that we would have multiple database instances or multiple database nodes sharing a common set of disk drives. For example, what we see here, I have node 1. This happens to be a virtual machine, but its own standalone virtual machine. And if I come over here, I have node 2. Each individual node has their own separate SGA, has their own separate set of executables, and their own separate set of background processes. However, both nodes will share this common set of disk drives. So in the event that a user is going to connect to a specific node, if that node goes down, Oracle will fail over to the surviving node, thus eliminating a single point of failure. In a typical single instance environment, your application is going to connect to one node or one instance, where there's a one-to-one relationship between instance and database. In a RAC environment, there is a many-to-one relationship between database and instance, meaning that a database or a set of data files can serve many instances. So in this particular case, we will have node 1 and node 2 running. Those will be their own separate set of instances. They will have their own SGA, their own background processes. They will share the common set of data files. We will have one common set of data files. So we will have data files, control files, online logs, as well as archive logs. Actually, in a RAC environment, each individual node will have their own set of online logs as well as archive logs. But the common set of data files will be data files and control files. So again, what happens is an end user or an application, they will connect to a logical service, and that service would be something like HR, and the HR service can be routed to node 1 or node 2, and then node 1 or node 2 or both nodes will actually be pointing to the exact same set of data files. The whole point of RAC, or Real Application Clusters, is to give our systems high availability. So when an end user connects to our Oracle system, they can connect to one node. If that node fails, they will automatically be reconnected or redirected over to a surviving node. We can also set it up so the select statement will continue to process. So the end user has very little downtime and they do not have to restart or redirect their session. So we can set up these systems so that when they issue a select, the select can go to a specific node. If that node fails, the select statement will automatically fail over to a surviving node, and then they will use the common set of data files. The other thing that you have to understand and remember is that a RAC system is designed for high availability. You could get better throughput, but you're not necessarily going to get better performance. For example, in a single instance environment, we have this particular node right here. If this is a single instance environment, and that specific node could handle 50 users, but in this particular case, we had 75 users hitting the node, then the node would be taxed and we could potentially have poor performance. In a racked environment, we could have multiple nodes, and let's say each individual node could handle 50 users. So in our prior example, if we had one node that was handling 75, now we can split it up and say, hey, each individual node might be able to handle 40 users. If a node is designed to handle 50 users, where each individual node is only handling 40, we're actually getting better throughput because our environment is dealing now with 80 users. So the Real Application Clusters gives us a couple of things. Number one, it gives us high availability. Number two, it gives us node failover. And number 3, it gives us better throughput, enabling us to handle more users without taxing a single node. In a racked environment, in Oracle 11 GR2, you will use the grid infrastructure architecture as well as ASM. In our particular case, for this particular course, we are going to be using Oracle's VirtualBox. We're going to be using Oracle's Linux as our operating system, and we also will have our specific networking set up accordingly. We will set up our shared disk devices so that each individual node can share a specific disk device. In our particular case, in this particular course, the node names will be Rack 1 for node 1, and if I come over here, the second node, I'm going to do a right mouse click and go to Open Terminal, and I can see here that this node name is going to be Rack 2. The whole point of real application clusters is to give us high availability, node failover, or application failover, as well as better throughput.